Hello, everyone. What I want to do is go over homework 7. The scores were actually quite a bit better than usual, with the median and average being around a solid B, so I was happy about that. Yeah, and I'll also discuss for problem 3, some people did a present value computation using a formula that I did not go over in class or in lecture video that sometimes works, sometimes doesn't work, and I'll explain that. And because it doesn't always work, that's the reason why I don't discuss it in lecture video. I think it's a rather pointless formula. It's not any quicker than not using the formula, and it doesn't work for problem 2, for example. And some people tried it. So yeah, I don't like it, but if you really want to use it, just be mindful of when it's useful, when it's not. But anyway, all right, so 20-year loan, nominal monthly interest is 3%, paid off with monthly payments beginning 1 month after the loan is made. So standard loan. Each succeeding payment is 3% larger than the prior, with the first being 2,000, find OB 48. So first and foremost, as usual, if J is the monthly interest rate, then monthly interest rate is just I-12 over 12, 0.0025. I-12 is 0.03, so this is what monthly interest is. All right, so first payment is 2,000. Second payment is 3% larger. Third payment is 3% larger than the second payment, etc., etc. Okay, so just like in the lecture example, this is just 2,000, 1.03 to the t minus 1. All right, so using the perspective method, we have the outstanding balance after 48 months is going to be just plug and chug into the formula, K49 times your present value factor, which is 1 over 1 plus 0.0025, 1 over 1.0025. So it's plus K 50 squared. Yeah, I do want to see like the whole sum. I want to see work done. All the way to the end, it's 20 years. 20 times 12 is 240 months. Then I remember it's well, it's really new, the Greek letter, but it's usually called V. V to the 240, which is N, minus T, which is 48. And this here is just going to be 1 second, what is this? 192. 240 minus 48 is 192. Let me just double check that. I think that's right. Yeah. Okay, so yeah, I have a common 2,000 here that I'll pull out. So this is just like the lecture video example. So K49, 2,000, 1.03 to the I won't, I'll actually do the whole thing. For some people who didn't really get this. Probably the biggest issue doing it here is just literally fitting it in here, but right small. So 2000, 1.03 to the 48. It's 49 minus 1 over V 1.0025. Okay, 52,000. 1.03 to the 49th over V squared. All right, last but not least, 1,000. I should be able to fit this. 1.03 to the 192. Sorry, to the 240. Over 1.0025 to the 192. Sure, that's easy to read. It's not much better, but it's 192 here. This is 192. Okay. Sorry. This is going to be 239. 240 minus 1. All right, anyway, so factor stuff out. We can factor the first term entirely, 2000, 1.03 to the 49 over 1.0025, and then use geometric series formula. Move this down. Sorry about that. All right, so yeah, over 1.0025 times 1 plus here we're gonna have 1.03 over 1.0025. So a lot of people had 1.01, or maybe like 4 or 5 people. I have no idea where 1.01 comes from. 3% increases. I didn't even have 1% in the prior year's homework, so that was really strange. But anyway, whatever. Okay, and last but not least, it's going to be 1.03 over 1.0025 to the 191. And check 48 plus 191 is 239. Yeah, and as I said, this is 192. It's really hard to read, so let me really just try and fix it real quick. It's better. Right, 1.025, or rather 1 plus 191 is 192. So yeah, it's definitely it's the correct number here. We get the last term here. All right, so it's just geometric series formula. Plug and chug into your calculator at this point. 1 minus my R, 1.03 over 1.0025 to 192 over 1 minus your R. Okay, yeah, and I'm not going to do this in the calculator. You can do it yourself. Actually, I don't remember what this is, so I will do it in the calculator. I would do, probably the easiest thing to do is to save 1.03 over 1.0025. Do 1.03 over 1.0025. So let's store it in the one spot. We take this to the 192. Make sure that's right. Probably is, but do it again. Yeah, okay, so make this a minus plus 1 over 1 minus, we call 1. All right, this whole thing times 2,000 times 1.03 to the 48 over 1.0025. Get 5395326. And there's a 1.03. All right, on to the next question. The 40-year, $150,000 loan is made. Effective annual interest is 3% for the first 15 years, 4% for the next 25 years. Yearly payments of K for the first 15 years, and 1.25K for the next 25 years. Find K, find these outstanding balances after the 15th and 25th year, and fill out the amortization table. So a lot to do, but yeah. All right, so here's a time diagram, and I definitely suggest doing a time diagram for something like this. Okay, so for the first 15 years, payments of K at the end of each year. Then it becomes 1.25K. Yeah, I don't know of a quick, easy formula to take the present value of all these payments, just break it up into two annuities, and that's that. I mean, that's pretty quick, so I don't really feel like there's a need for a quick and easy formula. But anyway, I mean, more on that for the next problem, where there is an easy way to do this. I'll talk about that for number 3, slightly quicker way, I guess. All right, so loan amount is 150,000. So take the present value of your first K payments, KA 15. And sorry, I forgot. Interest is 3% for the first 15 years, and then 4% for the next 25 years. And this should be, 39 and 40. Very silly on my part. Anyway, 0.03. All right, that takes care of these. Now let's take care of the other 25 payments. As always, it's just the same present value. That gives me present value at t equals 15. So I discount it by 15 years. K, A, 25, sorry, 1.25. So a lot of people did K. Well, it's 1.25. It's not just K. So 1.25K. I don't like that. It's really scrunched up. That's a little better. So it's 0.04, and then we discount this by it's still scrunched up, but anyway. Yeah, discount this 1 over 1.03. Discount this by 15 years at an interest rate of 3%. Yeah, and you'll get 11.93794K plus 12.53402K. So just add up, solve for K. K is 6129. I think it's 6829 if you did not do the 1.25K. Roughly 46 cents. Okay. All right, so let's do the outstanding balances. So I don't have constant interest and I don't have constant payments, so I cannot use my formula where we have constant interest and constant payments because we don't have that. If I really want to, I can do it when I do the loan reset. If I reset it after 15 years, then for that new quote unquote 25-year loan, I'm going to have a constant interest rate of 4% and a constant payment of 1.25 times K. Well, K is 61.2946. So 1.25 times 61.2946 is at constant payments. But when I'm just doing OB15, the outstanding balance after 15 years, in this loan, I don't have constant interest and constant payment. I need both to use that formula. Okay. Doesn't matter that I have constant interest, constant payment for the first 15 years. Throughout the whole loan, I don't have constant payment and constant interest, so I can't use that formula. Okay. But as I've said before, this formula is not really a big time saver. So if you never want to use it, then you're probably safer just never using it. All right, anyway, so 150,000 times 1.03. So I do have constant interest and constant payments for the first 15 years. So I'm going to use this formula. I'm allowed to use this formula. Kind of the other one, 46409. So it's S15.03, and this is going to be 119,693, 7377. All right, so I do a loan reset. So yeah, I want the outstanding balance after 25 years. So yeah, so just to emphasize this, I'm kind of thinking this is really 10 years. into the new loan. But I actually had someone write OB25 and then write OB10 because it's 10 years into this new loan. I mean, technically that doesn't make sense, but I'm happy if you do that because that says to me you clearly understand what you're doing. So yeah, that's fine if you want to write both of them. But anyway, running out of room. All right, so in that formula, we're going to use t equals 10. Okay. So, right. So the new loan amount that I owe at the beginning, or the new loan amount, the original, this new outstanding balance, this new loan amount is going to be 119,693,7377. So plug in 10. And for this new loan, interest is 4%. It's 10. Again, 10 years into this new loan, 10 years after 15 is 25. Minus the payments for the last 25 years is 1.25 times K. So it's 1.25 times 6129.46. So that's going to be 7661. 68061. Sorry, 83061. S10.04. We're going to plug in t equals 10. And we get 85, 187, 21. Okay. Yeah, for the amortization table, most people got that, so I'll be quick. So yeah, the payments for the certainly for the first 3 years are 6129.46. All right. Interest is 3%, so 150,000 times 0.03 is 4,500. So take 661.29.46 minus 4,500. I get 1029. Sorry, 1629.46. $150,000 minus 1629.46 gives you 148. $370.54. Right. So now we take this. I'll just do the net interest for second interest payment, then just write out the answers for the rest of it. So this just accrues 3% interest on this new outstanding balance, 148, 370.54. Looks like a 9. So this is going to be 4451. Yeah. 445112. All right, so take the payments, subtract this. You're going to get 167,834. Take 148,370.54 minus the principal repaid. 146,692. So if you don't learn anything or if you learn very little in this course, I'm hoping at least dealing with loans is giving you appreciation of why loans and mortgages, student payments, student loan payments, mortgage payments, just you can lose a lot of money if you're not careful with loans and mortgages and whatnot. Doesn't necessarily mean you always repay it as quickly as possible. If you have a better place to put your money, which right now I don't know what that is, but when the stock market was hot, for the many years where it was hot, if you had a low 3-4% mortgage, it'd be silly to pay that off quickly. Invest it in S&P 500 or something, get better return. Now, not really clear what to do. And with high interest rates, maybe it is a good idea to pay off as quickly as you can a mortgage you might take out. But anyway, hopefully this is giving you appreciation for, loans and mortgages and paying them off and all the interest payments that you have to do. All right, take 146,692.20 times 0.03, 440079. Let me just write these out. If you have any questions, again, most people did as well, so probably shouldn't even spend time writing this, but whatever. All right. Yeah, actually, real quick, one person did 150,000 plus 1629 46. It's always minus. You're always subtracting off from your outstanding balance unless the principal or paid is negative, but still you're subtracting off a negative number then, which makes it plus like we do in this example. Okay, so yeah, interest capitalization problem. And very practical to understand this and to be very careful to avoid this kind of situation if you can. You have a loan with a nice and high interest rate, 7%. Very high. 15,000 20-year loan. So originally I had 10,000 and I sent everyone an email saying, hey, it's 15,000. 12 payments of X followed by 8 payments of 6X. Okay. So let's first get what X is. Okay. Same, I'm not going to draw a time diagram, but it's exactly the same logic. So you should be able to draw a time diagram. So you have 15 payments at K. Sorry, doing problem 2 again. You have 12 payments of X. I mean, when you do this problem, I would suggest doing the time diagram, but this is already getting a little long, so logic is exactly the same. You have 12 payments of X followed by 8 payments of 6X. So actually, I guess I can draw a time diagram. Make sure we're all on the same page here. 8, 20. So now it's 6X. Okay, so present value of the 6X payments occurs at, or gives us the present value of T equals 0. That's what T equals 8 using the standard present value formula. So 6X, A8, 7. Interest is just 7% throughout. So we have to discount it by 8 years. All right, so we get 150,000 is 7.94269. So for the amortization table, I'll probably just do the first row and then just write out what the rest is. Plus 15,90797 X. So solve for X, 620 $891. Okay. The one thing I want to emphasize is, so yeah, in this case where you have these payments here, sorry, so it's 12 payments, so this should be a 12. $13. Yeah, so when you have a situation like this where you want the present value of these payments that I'm circling, and you have a constant interest rate throughout your entire loan, and implicitly here I have this constant payments of 6x, maybe not constant prior, but when you have this situation of a constant interest rate throughout the entire loan, you can get the present value of these payments by doing, now let's check it. Again, this calculator is very small and I can't make it any bigger. But anyway, a little closer, tough for me to read. All right, so the formula is, I'm loath to even go through the formula, but people did it, so I'll explain how it goes. So it's A, so let's say this is K here and this is N. So it's AN, which is 20, minus AK, here it's 12, all times their payment of 6x. Okay. 20N, 7, payment, 1, sorry, 20N, 7, interest, 1, payment, compute, present value. All right, so I'll make that a positive. Store it in the 1 spot. And let's do 12. 1 second. Yeah, let's do 12 and 7, interest, 1, payment, compute, present value. All right, take this, make it a negative, plus this here. Yeah, times 6. Well, it'd be 6x, but yeah, 16.907967. So rounding, you would get 15.90797. Now, on the other hand, if we did that here, let's see what we get. Just kind of like a side note. I'll do it in a different color even to emphasize this, kind of like a side note. Okay, so here it would be 1.25K. So I want to show you that this does not give me the right answer in this case, because I don't have a constant interest rate throughout the whole loan. Okay. And if you're a math major, you should think about why this formula works and why it doesn't work if you don't have a constant interest rate. And I'll leave that for you to do if you so desire. Yeah, I mean, I think it's a good exercise, especially if you're an actuary major. Definitely, it's a good exercise to do that. Think about why it works when you have a constant interest rate throughout the loan and why it doesn't work if you don't. All right, so this, yeah, so here K is 25. Sorry, K is 1 second. Yeah, so it's 15 here. About that. So it'd be A40.04 minus A15.04. Let's see what that is. So I can clear the M, 40N for interest 1, payment, compute, present value. Make that positive, store it in the one spot. Now let's do 15N for interest 1, payment, compute, present value. Times 1.25, and we get 10.8429836. So it's off quite a bit. Then it's 12.53402. Okay. Now, if this was 4, if this was a 4, let me just write this down. If I did have 4% interest throughout this whole loan, then let's check that we would actually get this. Okay. So if it was 4% for the entire loan, then this would be 1.25 payment, 25N for interest, compute, present value, times 1.04. I'm saying if it was 4, it's not, but if it was 4. So lo and behold, we got the same answer, 10.84298. Exactly what I get here. But because it's not the same interest rate, it gives you the wrong answer. So again, I don't like this formula. I think it's important to understand the idea of breaking loans and annuities up into multiple annuities when you have an interest rate change or a payment change. But that's just me. So yeah, and as you've figured out by now in this course, if you don't understand things, you're gonna probably do really poorly. All right, anyway, so 628 91. So get the outstanding balance. I'm sorry, there is no outstanding balance here. All right, so yeah, do this quickly. So 628 91. All right, so 7% of 15,000. $10.50. All right, so it's still the same formula, 628.91 minus 10.50 minus 42109. So it's 15,000 minus 42109. That's a 9. This is going to be difficult. Let's see if I can do this. I should have plenty of room. Go out of the box, but that's all right. So this is 15 87166. So you just added I'm sorry, that doesn't make sense. this is negative. You've 421.09. You've added 421.09 of interest to your outstanding balance, so you have 421.09 as your new outstanding balance. And then this would be 1079, roughly 48 cents. Minus 450, 57, 15,871, 66. 7% of that is roughly 11,111. Sorry, 1111, 2 cents. 42.11, 16.3. So I haven't actually checked carefully, but well, I think it's pretty obvious, or it should be kind of obvious what would happen is that finally, once you hit 13th payment of 6x, then and only then you're going to start to chip away at your principal, because you're paying quite a bit then. Instead of 628.91, 6 times that, you're paying almost 30, probably over $4,000 each year after that. So but anyway, all right, hopefully this was helpful. And yeah, there's only one more week, so I'll finish up loans and module 8, then talk about bonds in module 9, and I think just a little bit of internal rate of return and stuff like that. I have to check, I'm not sure, but basically we're almost done. Yeah, pretty wild to think, but the course is almost over. All right, so long, take care. Have any questions, let me know. Bye-bye.